Okay, so now let's continue with the second type of isomerism, that is on stereoisomerism. So after the constitutional isomerism, okay, we have the second one goes to stereoisomerism. Okay, so according to the description, to predict the existence of stereoisomerism, we can refer to this point, okay, in which stereoisomerism, okay, is referring to the existence of organic compounds having the same molecular, same connection of atoms. So this one is crucial. This one is to be highlighted because this mark the difference between stereo from the constitutional just now. For constitutional just now, the compounds having same molecular formula but different connection of atoms. For stereoisomerism, the connection of atoms is the same. We don't change the connection of atoms. But what is the difference between the compounds for the stereoisomerism? This one, the third point is to be highlighted. How the atoms are arranged in space is different, or it has different, or they have different orientation in space. So we are going to talk in terms of their orientation, top, bottom, okay, or left and right. So that is the stereoisomerism. Okay, and there are two types, or there are two classes of stereoisomerism, okay, which are known as cis-trans isomerism, or sometimes we call them as geometrical. Okay, geometrical isomerism. Okay, but let's use cis-trans because it can give reflection on what types of isomers we can have, in which we are going to have two isomers, namely cis isomer and trans isomer. There are two isomers. That's why we call them as cis-trans, okay, isomerism. And the next one, the second, is called optical isomerism. So optical isomerism. And in terms of the criteria, as you can see here, this is the basic. This is the basic or essential requirement. Okay, but actually the requirements is more than what is listed here. But this is the one that we cover in our syllabus. For example, okay, for cis-trans isomerism, okay, the isomers must contain carbon double bond carbon. This is what we covered in syllabus. But actually, it is not limited to carbon double bond carbon only. Okay, we can also find the cis-trans isomerism or cis-trans isomers for cyclic compound. Just that we don't cover that one. So, if you are given carbon double bond carbon as the compound or contains in the compound, okay, you can consider for the possibility of the cis-trans isomers to be exhibited, okay, or to exist. But then, not all carbon double bond carbon can form the cis and trans isomers. Only selected carbon double bond carbon. So which carbon double bond carbon? Refer to the next point. Okay, in which each carbon double bond carbon, so each of them must be attached to two different groups. Or I can redraw like this. Okay, this one. So we have carbon double bond carbon. Okay, to show the cis-trans isomerism, but not all carbon double bond carbon can give the cis-trans isomers. Only carbon double bond carbon in which each carbon attaches to two different groups of atoms. For example, carbon here, the first carbon on the left attached to hydrogen and attached to Cl, for example. And the second carbon double bond carbon also having different group of atoms. Okay, it can be totally different from the first carbon, or it can be the same group. For example, second carbon also has hydrogen and Cl attached to it. But still, the requirement said that each carbon. So we have to consider one carbon, each of them, one by one. So the first carbon, two different groups, pass. Second carbon, also two different groups, pass the requirement as well. That's why this is the example where the organic compounds, okay, can show the cis-trans isomerism. And when you have cis-trans isomerism, dia akan wujud dalam dua bentuk isomer yang kita panggil sebagai cis isomer and also trans isomer. So which one is cis and which one is trans? Let's discuss in the next slide. But before that, okay, let me complete the requirement for the optical isomerism. For optical isomerism, very straightforward. The requirement is that organic compound must contain at least one chiral carbon. So you have a lot of terms being introduced here. Okay, so hopefully you can catch up. Okay, you can remember. So chiral carbon. So what is chiral carbon? Chiral carbon, also known as asymmetric carbon. Are you familiar? Asymmetric? Asymmetric means what? Asymmetric means not symmetry. Balance. Asymmetry means not symmetrical. Asymmetry means not symmetry. Tak symmetry. Okay, in which to be chiral carbon, the carbon must be bonded to totally 4 different group of atoms. Okay, all the group should be totally different. That is called asymmetric. Asymmetry, not symmetry. It is not the same at all. So all the 4 should be totally different. For example, 2-butanol. Okay, this is an example. The one that I have expanded, the carbon that I show in expanded structure, okay, is said to be chiral carbon. And usually, how do we differentiate or how do we highlight the existence of chiral carbon is by using asterisk symbol, star. Kita put star because that carbon is very special because we call the carbon as chiral carbon. So, can you see the 4 different groups attached to it? The carbon has 1 hydrogen, 1 CH3, 1 OH group, and the remaining 1 group of CH2, CH3. So there are totally 4 different groups. So that's why the carbon here, okay, is called chiral carbon. So if the compounds containing chiral carbon, then the compounds can exhibit, can form optical isomerism. So what is the optical, or what are the optical isomers? If cis-trans, we have cis isomer and trans isomer. And how about the optical isomers? We are going to see in the next slide. Kalau sempat lah. Okay. So now, can we continue with cis-trans?
Yes.
Boleh Okay, kita ambil masa sikit you all. Okay, since we have another 10 minutes more, okay, let's try to make use this. Did you have class at 12?
No.
Tak ada so kita ambil masa you all sikit Okay, let's discuss. Okay, since I have given you the introduction kan about cis-trans and optical, okay, so let's complete what are the inputs, okay, under them. Okay, so cis-trans or geometrical isomerism found in some alkenes. Some alkenes, take note, not all alkenes can show the cis and trans isomers. And what is the reason or what makes these cis-trans isomers to be exhibited or to rise? So this is the what we call that factors. This is considered as factor that give rise to the cis-trans isomerism. Because sometimes, if I'm not mistaken, there was assessment asking the student why the compounds can exhibit, can show the cis-trans isomerism. So the answer is because or the existence of cis-trans isomerism is due to the restricted rotation of carbon double bond carbon. Or in other words, it is because carbon double bond carbon cannot be rotated. Okay, cannot be rotated. Okay, but if we insist to rotate the carbon double bond carbon, So that's why it gives rise to two new compounds, which are known as cis and also trans, in which they are now representing different compounds, because this is proven by different effects given by each of them. For example, here, this is in terms of the molecular or Bostick model. Okay, so let's have a look at here. So we start with the model at here. Okay, where we have the green, the gray sphere. Okay, the small gray sphere and the large green sphere at here. Okay, which we can draw into this. And the one thing about cis-trans isomerism, make sure you use template of trigonal planar like this. Okay, if the organic compounds can form cis-trans isomers, make sure you work with this template. So use this template for cis-trans. Okay, in trigonal planar. Okay, so now this one, this is the original structure. Okay. Okay. And if let's say we insist to rotate, we insist to have the rotation at the carbon double bond carbon. So when we rotate the carbon double bond carbon, then there will be changes on the position of one of the carbon, and it can be represented as this structure. Take note. Okay, when we rotate the carbon double bond carbon, we rotate carbon, one of the carbon, we rotate one of the carbon, okay, with the double bond that has double bond. Okay, then the position will be exchanged. Kat sini. On the left side is the same. Okay, this one sama. Okay, but the difference is at here. Okay, and take note, the connection of atom is still the same, but the orientation of the group in space is different. Kan? So now green sphere is at the top, while grey sphere is at the bottom part. So that's why these two compounds, okay, are said to be different compounds. And this is proven by properties of them. Okay, usually cis and trans isomers will have different physical properties. For example, in terms of boiling points, in terms of density. Whereas chemical properties, most of cases, they are the same because they have the same functional group. If you still remember, functional group give the chemical properties, kan? Since we have double bond, so by right, they should undergo the same chemical reaction, organic reaction. Okay, so now, how do we identify which one is cis and which one is trans? How do we know, or how do we come up with the cis and trans isomer? So this was very simple. Okay, cis means you are going to compare two identical groups at each carbon. For example, we have two groups which are identical at here. Kan? We can compare the grey sphere or the green sphere, any of them. But sometimes you have different groups appear on one of the carbon double bond. Okay, therefore, try to find one similar group. Okay, one similar group. So, as you can see here, if let's say we stick to grey sphere comparison, so if the identical groups are located on the same side, then we call it as cis. So cis means same side, okay, of the double bond. Cis, same. Okay, but if the identical groups are on opposite side, then the compound is called trans, or the isomer is known as trans isomer. So cis means same position, trans means opposite. Trans, tentang, bertentangan. Right? Okay, that is a cis-trans isomer. So is it clear so far? First, carbon double carbon. Thank you. So first is carbon double bond carbon. Second is each carbon must be bonded to two different group of atoms. And then you will get one cis and one trans. Cis means the identical group will appear on the same side, whereas trans will be on opposite side for the identical group. So I think for optical isomerism, let's reserve in the next discussion. Just that I want to share with you for more examples on the cis-trans isomers. This one, So these two are also known as cis-trans isomers, or show the geometrical or cis-trans isomerism. Cis-trans or geometrical isomerism, in which they are isomers. They can exist as cis isomer and trans isomer. So what would you say for the first structure here?
Cis.
Very good. And the second, of course, trans. Kan? So very good. So now you can get the point to identify the cis isomer and trans isomer. And same goes to the second. Kan? Kalau madam tukar, contoh lah. Madam nak tukar lah. Madam nak tukar. Tak nak lah L sini nak CH3. So sini nak CH3. So what would you say? Are they the cis-trans isomers?
Yes.
Yes, they're still the cis-trans isomer. So now, what to compare?
Compare the hydrogen.
The orientation of which group? Hydrogen lah kan? So choose the identical group. So for the first structure,
Trans.
Good. Last one.
Cis.
Okay, nice. So that is the cis-trans isomerism. Last one. Last je. I have one question here. So last, this one, betul, last. Yeah. So I'm going to give you a question. So please scan the QR code and write your name. Change anonymous to your name. Nickname ke tak kisah lah. And try to respond. The answer. Alright? You ready? So which of the following exhibit cis-trans isomerism? Kenapa tak boleh? Start presenting. Dah start presenting. Sekejap. Boleh tak keluar? Oh, madam tahu. Madam tak boleh guna iPad. Madam share screen madam kat sini. Sekejap. Okay. Start presenting. Sekejap madam share screen madam. Stop presenting. Okay. So madam share screen. So ready with your handphone, Okay, so be prepared with your handphone. Okay, so please scan the QR code and change the anonymous to your name, and then choose which of the following exhibit the cis-trans isomerism. Can you scan the QR code? Okay, so I have received two answers, two responses. Okay. So make sure you change voting as anonymous to change to your name. So that I can identify who's answered correctly. Okay, and who answered incorrectly. Okay, so this one would be the last part of our discussion, okay, for today. So inshallah, our next session will be on Friday at 8 AM. So inshallah on Friday, we will continue with the optical isomerism, okay, and the following part of the introductory. So inshallah, we will complete our discussion for the introductory part on this coming Friday. All right, only 10. Okay, only 10 responses collected. How about the rest? Okay, faster. Choose which of the following. Only 2 options given to you there. Okay, baru 12. Lagi yang lain. $15, $16. Danish Haikal. Danish Haikal, are you there? Tak ada.
Yes.
Danish Haikal, ada?
Danish Haikal bin apa main tu?
Danish Haikal, oh sorry. Danish Haikal bin Muhammad Effendi. Tak ada. Muhammad Danish Daniel? Muhammad Faisal? Pun tak ada. So maksudnya, I should receive 23. I should receive 23 responses. So waiting for another 3 more. Baru 20 ni. Baru 20 yang respon. 21. 2 more. Oh, line tak stable ni kot. Sebab ada yang... Okay, faster guys. Mana nak tutup dah ni? Okay, 22. Siapa yang tak respon tu, Madam suruh present masa untuk ni optical isomerism nanti next. Siapa tak respon yang ni, Madam nak suruh present untuk optical isomerism. Okay, done So another 5 seconds. 5, 4, 3, 2, 1. Okay, time's up. Very good. Okay. So we have 57. Oh. Majority opt for the first option. Kenapa? Wakil, siapa yang jawab ni? Siapa yang jawab option pertama? Kenapa pilih option pertama? Tak ada tengok siapa yang jawab. I have the data.
Madam,
Yeah.
I think because
Hmm.
the second one is different halogen atom.
Okey, kejap. Sini kan? Sini kan? In which you are provided by, kejap there are two options. First is C, okay, CH2, double bond, C, CH3 2, okay. And then second is CH, Cl, double bond, CHBr. Okay, but a majority choose this one. But actually the answer is this. What makes you choose the first one? If you expand it, if you expand the
Medium.
carbon double bond carbon, kan?
Medium.
Yeah.
I'm sorry, but we can see your present.
Oh, sorry. I just share screen right here. Okay. How about this? Can you see?
Yes, madam.
Okay. So majority opt for this one. Kan? But if you expand the structure, kan, carbon double bond carbon, and this carbon got 2 hydrogen, and the second carbon got 2 CH3 group. Like this. So does it fulfill the requirement for the cis-trans isomer?
No.
No. Jangan tertipu kan? Walaupun nampak macam, oh sini hydrogen, sini CH3 madam, but it is not the way you compare. You should check individual carbon double bond carbon tu. Okay, the carbon should be bonded to different group of atoms. So obviously this is not the answer lah. How about this one? Let's expand it. So we have carbon double bond carbon. So the first carbon here got 1 hydrogen and 1 Cl, whereas the next carbon got 1 hydrogen and 1 Br. So does it fulfill the cis-trans isomerism?
Yes.
So what is the isomer that I draw here? What we call it?
Cis.
Cis-trans.
Cis-trans.
Cis.
Cis, because hydrogen is located on the same side. Kan? So how do we get trans? How do we get the trans?
Different orientation of H.
Different orientation of, you can swap lah the position kan. It's up to you whether you want to swap the position of these two groups at the first carbon here, or you want to swap the position of these two. But you have to swap only one. Only one carbon double bond carbon to be rotated. So let's say you choose to rotate this carbon. So that's why the position of the two will be changing. So this one, you have Br ke atas and hydrogen kat bawah. Another carbon remains as it is. Jangan tukar, kalau tukar sekali remain. Sama pula, cis je. And this is called trans because the hydrogen now located on opposite side. Okay, so hopefully those who did mistake, okay, for this question, you can try more exercises in your workbook. Cuba to practice, okay, so that you are able to what we call that, identify which organic compounds can exhibit the cis-trans isomerism, and how do we draw the cis isomer and also trans isomer. Okay, I think that's the end, okay, of our discussion today. So alhamdulillah, thank you very much guys for the response. So please, okay, try to put effort. Okay, organic chemistry, how to score organic chemistry is through exercises. Okay, so please put effort. Since you're still at the beginning, okay, of the discussion, so this is where you have to start. Okay, rajin sikit je. Okay, buat exercise. Okay, and review. First review balik on the functional groups and homologous series tadi. Okay, and then try to work on the constitutional isomerism, followed by the cis-trans isomers. Okay, so that's all from me. Is there anything from you guys to add on?
I think no, madam.
Tak ada eh? Okay, so rajin sikit. Cuba buat exercises. Okay, so inshallah I see you on Friday, okay, for us to continue with the next isomerism, that is optical. Optical isomerism lagi challenging. Kita akan the difficulty level will be increasing. Okay, so you have to be prepared. So please prepare yourself, okay, with the knowledge that we have discussed during this session. All right, so Alhamdulillah, thank you very much, guys. So if there's no other questions, so let's adjourn our discussion with Surah to us and Tasbih Kafarah.